So guys, Math 3, we're going to look at using the quadratic formula today. This is a formula that you used some of you used it in Math 1, not everybody, but you all definitely used it in Math 2 to solve quadratic formulas, and we're going to look at it again to make sure that we're familiar and comfortable using it to solve quadratics. We spent a little bit of time in class showing where it came from. You know, we've been doing completing the square, and this formula comes from completing the square, but we're not going to show that here. So the next thing is we're going to solve a quadratic equation. The very first thing I do is recognize that I have to be equal to 0 to use a quadratic formula. So the first thing I did was subtract the 11 from both sides. And now I need to identify my A, B's, and C's. Alright. A is the coefficient of the x squared, so that's a 1. B is the coefficient of the x term, the linear term, is negative b. And C is the coefficient, or the constant at the end, is negative 11. And now I just use my formula. So I write down my formula. Alright, and I carefully substitute. Now I tried to color coordinate this so you see where they all came from. But negative b, okay, now my b is already negative. Now I wrote it down as negative negative. I will clean that up in just a minute. Some of you can skip that step and you can go ahead and change it, but I'm just going to wait till the end. I like to write everything down first and then use my calculator to simplify. To me, it's more consistent. So now I'm going to start doing some simplifying. Alright. So I ended up getting the square root of 144, which I liked. 144 is perfect, so I am going to go ahead and do that. Change that to 10 plus or minus 12 over 2. Okay, square root of 144 is 12. And now I recognize that this plus or minus means I have two problems to solve. I have 10 plus 12 over 2 and 10 minus 12 over 2. Okay, so be careful with this. Be careful with this. 10 plus 12 is 22, and 22 over 2 is 11. 10 minus 12 is negative 2, divided by 2 is negative 1. Take your time, run through that as many times as you need to. Okay, another example. This is a little bit more typical of our Math 2 problems instead of Math 1. Is to solve this problem here. Now, I've already gone ahead and identified the A, the B, and the C. Here's my A, my B, and my C. And now, of course, I'm going to write down my quadratic formula. So I'm going to start working on some simple substitution here. Negative B, of course, B is 6, so negative 6, plus or minus the square root of 6 squared. I'm going to subtract the 4 times the A times the C, so that's 4 times 2 times negative 7. And then that's all divided by 2 times 2 on the bottom. Again, I like to do all of my substitution first, and then I'll do simplifying afterwards. Negative 6 is already simplified, so I'm really worried about the inside. When I simplify the inside, that's going to end up giving me 92, which is unfortunately not perfect. Doesn't bother me though, because we've spent a lot of time this semester simplifying radicals, so I need to simplify that square root 92. So what perfect square goes into 92? Well, it's 4 times 23. Okay, so me just simplifying the square root of 92 into this, and I'll bring it back. Alright. There's one more step here, and that's because I recognize that there's a common factor between negative 6, 2, and 4. 2 goes into each of those. So I reduce it basically, and I get this. Now that is two different answers. And some people need to recognize that it's two different answers. I can use my calculator and find the estimate.
Do you have a white out?
Oh, wait, yeah.
Alright, last example for us. Again, this is Math 3, so we are a little bit more advanced here. Again, I have to make it equal to 0, so I add 10 to both sides. And then I identify my A, B, and C, which I've done again. Here's my A, my B, and my C. I'm going to run through the quadratic formula. I'm not going to spend a whole lot of time on this. I'm just going to let it run. And right here's where I stop. Why do I stop here? Because I recognize in Math 3 that this is the square root of a -4. That's an unreal number. That's not real. Now, in Math 1 and Math 2, I would say it's not real. But now in Math 3, I know how to deal with negatives, so I need to simplify that into my imaginary number. So we remember that -1, the square root of -1, is really the letter I. And of course, 4 was perfect, so it ends up being 2i. Alright. Take your time, guys. Look over this as often as you need to, and ask questions tomorrow. Thanks.